Okay. What I mean, you've probably already seen this. This is what it looks like when you are what your physics intro in lesson one. Um, Usually, I like to end the lesson with the actual homework assignment, but since we've already talked quite a bit and there's a lot of stuff on here, I'm gonna give you time to digest this. All right, and I'm going to introduce the concept of gravitational acceleration. Oh, you and add one more video that you might see about what's not in free fall. That's when you're out of deep dark space and there's no gravity pulling on you whatsoever. Okay. So you've seen the free fall on the moon. What happens because the moon actually has a gravitational attraction, so you can have free fall on the moon. Misconceptions of free fall. That's a very fun video to see. You might have a few questions in your pre-lab. So your pre-lab will cover some of the questions that I can answer, that I can ask you about things that you've seen on this. And they're all, and most of them are just fun. I mean, like this one's a 1.5 minute video. This one was too long. This track one of 13 minutes, eh. This one I got them down to the 3 to 5 minute um, level, so that's good. And Now we'll let's actually look at the free fall. Now you've got these slides. You've got these 3 slides, and this is the acceleration due to free fall. Now, most of you that are new to science probably have no idea what acceleration is. All right? You've got an accelerator on your car, and what does it do? It helps you speed up. Actually, you've got 3 accelerators on your car. Technically, in physics, you've got your pedal that you push on, the accelerator that makes you go faster. We think the acceleration makes us go faster. You also have another accelerator to deaccelerate, and that's your brake. And you also have an accelerator when you turn your wheel. You're accelerating towards the center of a circle, of the radius of the circle that you're. But we won't even go down that road. All right, in this class, that's for my 210 people to worry about. Now, this is like what free fall looks like on the moon. And you just saw a slide of that. And now, don't be afraid, but we're going to deal with this. Which equation? This equation right here for the distance that something fell. All right. For the distance that it fell, we're going to deal with this equation right here. And you're going, oh my God, what the hell is that? Not to worry. Not to worry. Trust me, I'm a doctor. All right. You'll be fine. So here we go. Well, let's just take a look at what free fall is. Let's get an idea, and I'll stop the lesson here, and then we'll resume tomorrow. All right. So here's what free fall is. Free fall means you already saw me like drop some things and we damn near shattered it. Basically, what we're going to be doing though, if I may, real quick, if I may show something here. This I know this is going to. All right, here's what. All right, you're going to take this. You're going to take this thing and you're going to use it on the meter side or whatever. You're going to take a ruler. You're going to. Somebody's going to have their hand here, and you're going to drop the ruler. And wherever they catch it, you're going to measure the distance. You know, you're going to get it right there on the zero with their hands, and then you're going to drop it. Whoop! You're going to drop it, and then calculate the amount of time it, what the reaction time was. All right. Now you can't do it yourself because I could go, okay. If you don't keep track of it, then you measure that distance. And here's the deal: when we look back at this problem here, when we look back at this equation here, notice there's a time here, there's the g here, the initial velocity is 0, and the initial height will be 0. So basically this y equals 1/2 gt squared is all you're solving. What do we mean by that? But first, let me explain to you what acceleration is. Okay, let me explain to you what acceleration is. Here's our notes. Okay, here's notes, and I always include these on the thing too. All right, so here's our notes. And the notes are acceleration. Acceleration is a change in speed over a change in time. Okay, so that means if we're falling at 9.8 meters per second squared, now 9.8 meters, that's like 30 feet. Okay, that means that means you're covering 30 feet a second, gaining 30 feet a second every second. So, within 3 seconds, you'll be almost going a football field per second in speed, which is really fast. If you think about it, that's almost 200 miles an hour, or even faster. So around 200 miles an hour. So gravity gets you going really, really fast, right? That's why these times that you're going to see, these reaction times you're going to calculate, are going to be really, really small. And so, an acceleration. Let's do one that you might be more familiar with, where we've got the acceleration of a, where you start from 0 meters per second. We do everything in meters per second. To 60 miles an hour is ballpark 28 meters per second. To 28 meters per second, and you're in my bad ride Mazda, and so we did it in 10 seconds. The change in time was 10 seconds. So my change in velocity was 28 minus 0 divided by 10, which gives me 2.8 meters per second squared, which is about 1/4, between 1/3 and 1/4 of what the acceleration due to gravity is. 1g is 9.8 meters per second squared. So my car has a whopping acceleration of about 0.4 g's. Some sports cars have about 4 to 5 g's of acceleration. Well, actually, it drags. The sports cars have about 2 g's, can get up to 2 to 3 g's. Usain Bolt has a 1g acceleration. It just happens for a very short amount of time. All right, so that's what acceleration is. And so when we talk about the acceleration due to gravity, that means after 1 second, you'll be going 9 point. If you start with 0 as your speed, meters per second, after 1 second, you'll be going 9.8 meters per second. After 2 seconds, you'll be going 19.6 meters per second. After 3 seconds, see what I'm doing? You're just adding 9.8 meters per second for every second that you fall. And so it gets very, very fast, very, very quickly. And what you're going to be doing is so that when you drop something, so we wind up with this equation after a lot of calculus, a lot of messing around, that the distance, and now I'm going to make the 9.8 positive and all that kind of stuff, that the distance it fell is equal to 1/2 g times t squared. All right, so how do we solve for this? We go 2y, multiply both sides by 2, is equal to gt squared. Now we're going to divide by g. We get 2y divided by g is equal to t squared. And so t is equal to the square root of 2 times the height that it fell, y, divided by 9.8 meters per second squared. And you have to do the height in meters, and we'll talk more about that later when you get to your experiment. All right, that's enough for you to digest right now. And I'll publish these notes probably tomorrow, but you can see it's just 1 page so far. But when tomorrow I'll open up your actual lesson for Lab 1, and we'll take a look at it. And I'll add more notes.